Hello everyone, we're the Brain Cells, and today we're going to be explaining and thoroughly diving into the project of Arduino. We will be teaching you step by step on how to code, how to assemble, and explain each parts and their importance in the projects. In the process, my group mates and me will explain it to you on how it's processed. We have Sir Hans, who will be editing the videos. We have Sir Ace, who will be explaining how the assembly is work and thoroughly strategize. And we have Sir Galib, who will explain the parts and its importance. And me, yours truly, will explain the code and thoroughly dissect it to easily teach you on each of its importance. Without further ado, let's go into it. The Brain Cells presents Arduino Project 12 RGB Light Dimmer.
One is jumper cables Male-to-male jumper wires used to connect components on a breadboard or directly to Arduino pins. And the second is resistor 220. Electronic components that resist current flow to protect LEDs or control current in the circuit. And the third one is Funke potentiometer, variable resistor that allows adjustment of resistance, often used for input, brightness, and volume. And the lastly is 5mm RGB LED, multicolor LED that combines red, green, and blue in a single package to create different color.
Hello everyone, my name is John Stephen, and today I'll be the one to explain how the code works in Project 12. So, in this project, we're using 3 potentiometers to control the brightness of an RGB LED. So, to anyone who doesn't know what an RGB LED is, an RGB LED has 3 colors inside it. There's red, green, and blue. By mixing these 3 colors, we can make almost any color. So, firstly, we connect the red, green, and blue pins of the LED to the Arduino pins 9, 10, and 11. These pins support PWM, which means we can adjust brightness levels instead of just on or off. Then, we connect 3 potentiometers to the analog pins A0, A1, and A2. Each potentiometer acts like a dimmer knob for one of the LEDs called. In the setup function, each pin mode is set as an output to display the dimness or brightness of each color, allowing them to mix together and creating a new variant. And serial.begin is also added to initialize the serial port. Next, in the loop function, the Arduino reads the value of the 3 potentiometers. Each value goes from 0 to 1023, but PWM only works with numbers between 0 and 255. So, we use the map function again to scale them down to the right range. After that, those numbers are sent to the LEDs using analog write. This changes the brightness of the red, green, and blue parts of the LED. So, when you twist the knobs, you can change how much each color is on, and the LED mixes them to create a new color. The program also prints the values for red, green, and blue on the serial monitor, so you can see exactly how the brightness of the numbers as you adjust the knobs. The color RGB function just makes the code neater. It takes the 3 brightness values and applies them to the LED pins.
And this is the project number 12, the interactive RGB LED that is controlled by 10K potentiometer. So the components you will use here are 3 10K potentiometer, jumper wires, resistor, and RGB LED. So the first thing we do here is to attach the jumper wire and resistors. So you need to be careful here since one mistake can affect the entire project, especially the 10K potentiometer. So after attaching the jumper wires and resistors, we will now attach the 10K potentiometer. So what will happen on this project is you can control the light that can emits by the RGB. So you can make it green, red, blue, or you can mix it according to your wants. So now we will attach the jumper cables on 10K potentiometer. We'll attach it to the ground area. So all the jumper cables from 10K potentiometer was attached to the ground area. So as you can see, it's turning red, and you can mix the color according to your want. So now it's blue. You can turn it up, you can turn it on, and that's all.